Okay, hi, welcome friends. So, we're going to start today with just a short lecture on this concept of acid rain. How does acid rain happen? What are its effects? So that we can more fully explore it throughout class later today. So, we've got to kind of back up and talk about the pH scale. So, at a chemistry level, the pH scale stands for potential of hydrogen. And really, it's a measurement of how many hydrogen ions are in water. And these are charged hydrogen particles in water. The more hydrogen ions in the water, the further on the acidic scale it is. So a 0 would mean a lot of hydrogen ions. The fewer of these hydrogen ions, the more alkaline or basic, sometimes it's called, things are. So on either end, you kind of have these extremes, really corrosive, potentially dangerous materials. Neutral, pure water would be considered basically an equal number of hydrogen and hydroxide ions, which are a different ion, but it's considered neutral. So when we talk about rain that is pure would be at a 7. So when we talk about acidic rain, we're talking about things that have more hydrogen ions than typical water. So what is it that makes rain acidic in the first place? So again, if pure water is a 7, when we add other ions, they can include hydrogen ions, which can lower the pH. There are other ions that can be added to water that can increase the pH. So you might have seen sometimes there's like a popular thing right now where certain waters you can buy at the store have a higher pH. Those are supposed to be ideal for after workout because they're replenishing some of the ions that we lose through sweat. So those have a higher pH, but in the case of acid rain, we're looking at a lower pH. There are two main culprits that are contributing to this, and we've talked about them. Nitrogen oxides, which come from vehicle emissions and from the burning of fossil fuels. The big one we talk about with air pollution is nitrogen dioxide that's released into the air. Sulfur oxides come largely from when we burn coal as a fossil fuel. So remember, oil, natural gas, coal are all different types of fossil fuels. Coal is still used really widely, both in the US and in other parts of the world, as a power source. So you have large factories that burn coal to get power and energy that is sent other places, and those sulfur oxides enter the air as well. So when they enter the air, they react with the water vapor that's already in the air, right? This is just water that's evaporated as part of the water cycle. And this is going to form sulfuric acid and nitric acid. Overall, this is lowering the pH of the water that is in the atmosphere, and then that water falls back to Earth, right? It could be as rain, as snow, sleet, etc. But in any form that water takes to come back to Earth, if it has encountered these nitrogen oxides and sulfur oxides, it's going to have a lower pH. So we've got just kind of an image here that shows you near a factory that is releasing sulfur and nitrogen oxides into the atmosphere. Those combine with the water vapor in these clouds to create the acid rain. That acid rain tends to fall downwind from where these large factories or big cities that are emitting a lot of these pollutants into the air come from, because they're going to come in places with lots of cars or where a factory is happening. So what's the effect of this? So when it hits soil naturally can do something that we call buffering. This is the idea that soil's bedrock, or the parent rock that it comes from, when we talked about the parent layer of soil in the soil horizons, if it is something like limestone and marble that's already alkaline, it essentially neutralizes that higher pH, keeping the soil pH at a pretty stable level. In some soils, like our soil around here, the bedrock is granite, and granite is not as alkaline and not able to neutralize this. So the overall soil pH becomes more acidic. Now, this is problematic for a few reasons. We know soil relies on microorganisms to keep that soil healthy. Organisms have ranges of tolerances, and microorganisms, bacteria in particular, often don't have very big ranges of tolerance. When it becomes more acidic, we see that the level of soil nutrition decrease as those microorganisms die. in addition to the fact that the acidic soil releases aluminum that has been stored into the soil, and this aluminum is toxic for plants. So we saw that image at the start of class of the trees that had just died. All their leaves had fallen off. It's because of this aluminum and degradation of the soil. Now, water. Bodies of water like lakes and ponds, rivers, can also be affected by this, particularly standing bodies of water like ponds and lakes. Now, this might happen because of runoff. If you've got that acidic soil next to a body of water, or in the watershed of that body of water, the water is running off and carrying the acidity with it into the lake. The rain itself that is falling could be acidic. And then we know water is stored every year in snow and ice. So during the summer, that snow and ice melts, and large amounts of that water then drains down a mountain and into lakes at the base of those mountains. These lakes in mountain ranges actually have this experience of really acidic waters pretty frequently because there's so much snow melt that is feeding them, and it can be really acidic. The organisms there, just like we already said, display a range of tolerance to pH. So when the pH of the body of water drops low, it can threaten the ecosystem. Depending on what organisms live there, what that exact number is going to be is going to depend, but really, scientists know that even at around 5 or 5.5, we're seeing effects on ecosystems. In particular, crustaceans, so things like shrimps and crabs that form an outer shell and are often bases or toward the bottom of a food chain, will start having their shells soften or even dissolve. So that acidification is really dangerous to the crustaceans. And then plant life and other organisms can also die as a result. So as you can see, very disruptive to these ecosystems. So again, we see this image from this power plant. It falls back to Earth in many different ways. It reaches the soil through both rainfall and runoff and snow and ice melt. You see that snow and ice melt coming from the mountain there. Ends up in bodies of water, threatening the aquatic life that is there. Now, the bright side is, in the US at least, the amount of acid rain and the acidic levels of both our soil and our water has improved dramatically since the Clean Air Act was passed. There's a lot of evidence that there is less acid rain and less acidification in our waters and soils around our country because of the Clean Air Act that we've talked about before.